Allie. I'm an intern at the Headwaters Science Center, and today I am joined by
Savannah. I'm a volunteer here at the Headwaters Science Center.
And today we're going to be discussing a little problem we're having here at the Science Center. As you can see behind us, we have one of our most famous exhibits, the bubble wall. It's one of my favorites, and I was young, and still I really like it. But recently, it's been acting a little weird. We think there's something wrong with the soap we're using that produces the bubbles. They're just not as durable, they pop really easily. So our problem that we need to solve today is, how are we going to fix this solution? We think our main problem has to do with the soap we're using. It looks fine to me, right? And the soap that Savannah has, it looks like the same thing. However, recently the Ultra Joy brand was bought by another company. So this is P&G, and Savannah, what does that one say?
This is under the brand Joy Suds.
Interesting. We think maybe the formula changed, and that's why the bubbles are changing. Savannah, how are we going to solve this problem?
We're going to solve our problem by using the scientific method. And in our scientific method, we'll outline our problem, which Allie just talked about, and then we'll do our research, come up with a hypothesis, and then do our experiment. And then after the experiment, we'll evaluate our results.
That's awesome. So like we talked about before, we've already addressed our question. So next we're going to go into our research phase, which include learning about the formation of bubbles, how bubbles are made, and most importantly, the ingredients that are most commonly found in some of these soaps. After that, we're going to test to see if maybe the water has something to do with the bubbles, such as RO water, which is filtered water, so it's very pure, or just regular tap water. Then we'll be testing all sorts of different brands of soap. I think we have 7, is that right?
Yeah, 7 different kinds.
We're going to narrow it down to 3 soaps, which we will then use in our experiment on our bubble wall. And once that's all over, just like Savannah said, we'll evaluate our results. Should we get started?
Let's do it.
Now we're going to be testing to see if RO water or tap water works better to produce durable bubbles. RO stands for reverse osmosis, or a process we can use to filter out contaminants in water. Reverse osmosis removes between 90 and 99% of contaminants that can be found in water. So the difference between RO water and tap water is that RO water is very filtered, whereas you might find some contaminants such as minerals in normal tap water. For this experiment, we will be using the original Joy Suds formula to test our water. It is important for this experiment that we use the same soap and measure it correctly so it's constant. We can refer to this as our controlled variable. At the end of this experiment, we will be picking either RO or tap water, depending on which one produces the most durable bubbles and least amount of suds. Let's start with RO water. If we look at our footage, you can note that the RO water bubbles are pretty big, but it produced more small ones and big ones, and the smaller ones tended to pop pretty quickly. Now let's move on to tap water. If you look at our video footage, you can see that the tap water bubbles were far more consistent in size than the RO water bubbles. They were also more durable. We will now be testing for sudsiness. Our soapy RO water does not seem to be producing that many suds, and the ones it does produce seem to be pretty small. When using the actual bubble wall on the exhibit floor, if a formula is too sudsy, the bubbles sometimes pop too early. This means the less suds, the better. Here, soapy tap water appears to be more sudsy than soapy RO water. After analyzing our results from both RO and tap water, we decided that tap water should be used in the bubble wall because it has more consistent bubble size. Now we will be narrowing our soaps down to 3 contenders. Let's talk a little bit about some of the research we collected. Soap is a reaction between fats and a strong base. A soapy solution is needed to create bubbles. When stretched across a surface, it forms a thin, filmy sheet with fairly low surface tension. If we blow on this thin sheet, the surface concentration of soap lowers and the surface tension rises, giving the bubble a round shape. Bubbles are round because it's the shape that puts the least amount of stress on the surface layer. When too much stress is put upon the bubble, it pops. The first soap we are testing is Dawn. Our soapy Dawn solution created 3 medium-sized, durable bubbles. They were not quick to pop and overall pretty impressive. However, Dawn was also very sudsy, but as the video footage shows, it did not seem to affect the bubbles. Our second soap we are testing is Great Value. The Great Value solution produced 3 medium-sized bubbles, the second even gliding across the surface for a while. However, the solution was very sudsy and all 3 of the bubbles popped during the test. The third soap we are testing is Palmolive. The Palmolive solution produced 4 bubbles, all of which were a medium to small size. Palmolive was less sudsy than our previous 2 contenders, however the bubbles did not seem to be as durable. The fourth soap we are testing is Joy from the Joy Suds brand. Although we know this solution does not work well with the bubble wall, it's a good soap to compare the others with. It produces on average medium-sized bubbles that are not very durable, and the solution is very sudsy. The fifth soap we are testing is Joy from the P&G brand. We can no longer purchase this solution to be used on the bubble wall, but testing it can help us determine which soap is most similar to it. The P&G Joy solution was sudsy and produced medium-sized and fairly durable bubbles. The sixth soap we are testing is Ajax. The Ajax solution provided us with the most interesting results out of all the soaps. On the first trial, Savannah blew a large bubble, but it popped before leaving the wand. We also saw another bubble floating across the surface before hitting the side of the container and popping. This solution is most comparable to Great Value because the bubbles were not durable and the solution was very sudsy. The last soap we are testing is Gain. Gain produced 5 medium to small sized bubbles. These bubbles were not very durable and only 2 survived past the suds test. Gain was less sudsy than its other contenders, and the suds produced popped as soon as the test was over.
Right now we're going to be going around the Science Center and asking other employees and volunteers what their hypothesis is for what soap will work the best in our bubble wall experiment. Our 3 choices today are Dawn, Gain, and Great Value. Let's go. All right, Ryan, your 3 choices for soap, our final contenders, are Dawn, Gain, and Great Value. Which one do you think will be the best in our bubble wall?
Well, my call from the start has been Great Value because I think a cheap one is going to be one that's really good for making big bubbles. And as someone who works for the Science Center, I may be a little biased because I want us to have a cheap one. And that's bad science, but that's what I'm sticking with.
All right, thank you, Ryan. And now we have Ellie, another volunteer at the Science Center. What's your hypothesis?
I would say Dawn.
Dawn?
Yeah, that's what we use at my house, and we have a pretty shallow sink, but it always bubbles up over it.
All right, good reasoning. We're taking hypotheses from people at the Science Center on what soap they think will work the best in our bubble wall experiment.
Okay.
Our final soaps are Dawn, Gain, and Great Value. What do you think will work the best?
I think Dawn will work the best.
Dawn, any specific reasons?
Because I've used Dawn and it tends to make really long-lasting suds, and it has a degreaser factor that maybe will help eliminate contaminants or render contaminants ineffective.
All right, thank you, Chuck. So in our bubble wall experiment, we have 3 final soaps that we're going to be testing: Dawn, Gain, and Great Value. What's your hypothesis as to which one is going to work the best?
Well, I'll be honest. A lot of my hypothesis is based solely on the fact that Dawn is always scrubbing up cute little baby animals. So I think I'm going to vote for Dawn. But I'm very interested to see what the outcome is going to be.
All right, thank you, Angie. That was Angie's hypothesis. All right, Lee. So today our 3 soaps that we're going to be testing in the bubble wall are going to be Dawn, Gain, and Great Value. Which one do you think will work the best?
All right, so I want you to clarify for me what you mean by work best. So what is a bubble that's working best? What is a soap that's working best? What does that mean?
The soap that is going to be working the best will be the soap that has the biggest bubbles that are the most durable. And when we say durable, we mean how long they'll last without popping.
Okay, so I've had great fun watching the entire bubble exhibit, and it's really fun when the bubble goes all the way out of the exhibit and out onto the rest of the exhibit floor. So that's what we're looking for? All right. I'm going to start with which one I don't think it is. Right, you called it great value. I think that great value would leave me thinking that it actually isn't about bubble size, and it has more to do with cost of product. So I'm not going to pick great value for the sake of bubbles. So then the other two choices, and you brought them for me to look at, are gain and dawn. I'm going to tell you, I'd love to pick gain. I would love to, because that sounds like a big bubble, right? Gain sounds like a big bubble. But when I go to the store and I'm going to do any type of dishwashing with my hands, when I'm going to do that, I would go first and get dawn. So that's what I'd be picking. Now it does say 50% less scrubbing, which has nothing to do with bubble making. So I'm a little nervous about that, but I'm going to pick dawn.
All right, good choice. And that was Lee's hypothesis. Okay, Ridley, today in our bubble wall experiment, we have 3 different soaps we're going to be trying out.
Okay.
Dawn, Gain, and Great Value. Which one do you think will work the best?
Dawn.
Any specific reason why?
Nope, I just use that brand.
Okay, fair. That was Ridley's hypothesis. All right, Tristan, in our bubble wall experiment, which of the 3 soaps do you think will work the best?
Gain,
Any specific reason why?
because it's sitting right there.
Okay, good reasoning. Thank you, Tristan, for your hypothesis.
My name is Allie, and my hypothesis for which soap will work the best in our bubble wall is Dawn. I believe that Dawn is the best soap for our bubble wall because it contains a lot of ingredients that I believe will produce the most durable and big bubbles, such as certain ingredients that stabilize the formula and ingredients that make it sudsy so we can have bubbles.
My name is Savannah, and my hypothesis for what bubble soap will work the best in our bubble wall is Gain. And I think it will be Gain because Gain smells really good, and I want it to work because I want our bubble ball to smell good. And I really like the color. So those are my reasons. I think Gain will work the best.